Let's take look at an example of how to do some of these circuit diagram calculations, circuit schematics, and the math goes behind them. This will help you with your Ohms worksheet or your circuit worksheet. The Ohms worksheet should be pretty straightforward. So we're going to start with this basic equation. Okay? And now this looks really complicated until you start breaking it down into smaller and smaller pieces. Now, one of the very first things you should do in every one of these types of problems is figure out the equivalent resistance for the total circuit diagram. So the first thing we want to do is then take a look at parts that are in parallel and make them into an equivalent resistance. And so I see this resistor and this resistor are in series with each other. They should then add up to 20 plus 10 gives us 30. That equivalent resistor of 30 ohms is in parallel with this resistor in 10 ohms. Now to figure out resistance in parallel, it's 1 over. And so if we take 1 over the 10, that's here, 1 over the 30, that's here, that gives us 1 over 7.5. Reciprocate that, and then you have 7.5 ohms. Then add in this 15 ohm resistor and this 5 ohm resistor, and you end up with a total resistance of 27.5 ohms. Then you want to start picking off some of these different meters. Now remember, A stands for ammeter. In series, an ammeter, or the current, is the same in every place. So we're going to take this ammeter first. Current is measured by ammeters, is voltage divided by resistance. We have a voltage source of 60 volts. We have a total resistance in the whole circuit, 27.5. That gives us 2.18 amps. Now, the current has a choice at this spot. Some of it can go this way, some of it can go this way. Now, we want to look at the proportion. Remember, the lower the resistance, the easier the current flows. If the current goes this way, it only has to go through a 10 ohm resistor. If it goes through this way, it has to go through 10, 20, that's 30 ohms. 30 plus 10 is 40, and so 1/10 of that let's see, what did I say? 1/4 of the current wants to go through the more resistant path, and 3/4 wants to go through the least resistant path. So if you take the current that's heading in to this junction here, 2.18 ohms or amps, 1/4 of it wants to go this way, and 3/4 of it wants to go this way, because it's 3 times easier to go through here than it is to go through there. That gives you 0.545 amps. Now it becomes quite easy to solve for the rest of these values. Remember, voltage is current times resistance. We have a current of 2.18 times 15 ohms, gives us that. 2, we have a current of 0.545 amps going through this 20 ohm resistor. So that gives us that voltage. The third voltmeter is measuring half of the resistance. So half of the voltage should go through here. 0.545 times 10 gives us that. And we have 2.18 amps. Remember, the two currents combine at this point. So just like in this spot where we have 2.18 amps, we have the same in this series part of the circuit. 2.18 times 5 is 10.9 volts. Now, a way to double check that you've done this correctly. All of the voltmeters should add up to 60. And I believe if you take these 4 values, they add up pretty close to 60. Hopefully That helps you out on your circuit worksheet. Remember, the first thing, find equivalent resistance of the whole circuit by breaking up different parts that are in parallel, finding their equivalent resistance. Then find the current in the entire circuit. Then find the current in different parts of the circuit, and then start finding the voltages at the different voltmeters. Hopefully this helped. Make sure you communicate with me if you have any questions about the worksheets.